Welcome to another podcast. In this episode, we're going to be taking a look at the coefficient of variation. So I have sort of an example here to illustrate why coefficient of variation is important. We're also going to look at another reason why coefficient of variation is important in class. But typically, coefficient of variation is used when trying to compare data sets with different units or trying to get a consistent measure that's sort of not affected by units is probably a better way to state it. Let me remind you of what the coefficient of variation is. So we typically define coefficient of variation as the quantity CV, where CV is defined to be the standard deviation of the data set divided by the mean of the data set. And if standard deviation and mean are both in the same units, you see that those units cancel. So this is a unitless statistic, which makes it incredibly valuable. In mathematics, whenever you have quantities that you can calculate that are unitless, usually we call them dimensionless. Whenever you can calculate dimensionless quantities in mathematics, that's nice, because if the numbers change, if the units change, the statistic will not. So for this particular example, we have 5 data points. So the person whose height is 172, their weight in kilograms is 62, but they are in different units. And what I would like to know is there more variability, is there more dispersion among the height statistics or among the height data points than there are among the weight? In other words, are the heights more variable or are the weights more variable for this particular problem? And in order to do that, I'm going to have to calculate the standard deviations of each of these. And so let's just talk about the heights first. I'm going to calculate the CV for height. And in order to do this, I'm going to do a lot of the legwork in the calculator so we don't have to continue to do this by hand. So I want to start with the standard deviation. So I'm going to get the set, I'm just going to name my set height. And so my height is going to be equal to, and then let's put the data in, 172, 168, 164, 170, 176. So there's my height data set. And remember, the command to calculate the average is mean. So I want the mean height. And then I want to calculate the standard deviation of the heights. Okay, that standard deviation number turned out to be a square root. I want the decimal, so I'm going to solve it again. And we have the two values here. So we have 170 and 4.472. So the standard deviation here is 4.47213. We want to try to avoid rounding as much as possible because we want to compare the two values. And then the mean height was 170 centimeters. So we'll calculate that value now. If we take and divide the two together here, then we end up with the coefficient of variation for heights as being 0.0263. So we've got 0.0263, which you should always report your coefficient of variation as a percentage. And so the percentage in this case is 2.63%. So that is the coefficient of variation for that particular set. All right, now let's turn around and do the same thing for the other set. So let's look at weight. Calculate its coefficient of variation to be. So let's pull it back in, and I'm going to change up my sets here. So I'm going to go back and change this to weight instead of height. And change all the weight values here. So we've got 62, 57, 58, 64, and 64. Okay, enter. So now I need the mean of the weight instead of the height, and the standard deviation of the weight. and then we'll calculate its coefficient of variation to be the standard deviation divided by the mean weight of 61. All right, so there's our coefficient of variation for that problem. So let me go ahead and transfer all of this down. The coefficient of variation, the standard deviation was 3.3166247904, and the mean weight was 61 kilograms. When you divide those two, you get 0.05437, which gives a coefficient of variation of 5.4. Let's just go ahead and round it to the same decimal value here. So 5.44 in this case, percent. So comparing these two, there is more variability among the weights than there are among the heights. Because the numbers are different, if I had tried to use just standard deviation as a measure of variability, I would have gotten a higher standard deviation for heights due to the fact that they are bigger numbers. They're in different units. And so the coefficient of variation gives us a method of comparing the variability in data sets that is unitless. The size of the numbers doesn't contribute to it. Everything is zeroed out, so it's dimensionless, and all we get is a true sort of estimate of the variability in the data set. All right, thank you for watching.